PLC has two types of inputs. These are digital or analog in nature. Now, when we connect a PLC, that PLC needs to have a positive and a negative voltage supply. The negative voltage supply will tell the PLC what along with supplying power to the PLC. The 0 volts or the negative supply voltage will tell the PLC what the voltage is that it can expect to have at a logic 0 state or at an off state, and the plus V or the positive supply will supply the PLC with the value of what a logic 1 is going to be. So the plus V says what is a logic 1 or what is considered on, and the minus V says what is considered as a logic 0 for the digital inputs. Now digital is either on or off. Now if we consider our inputs, I1 and I2 are inputs. Let's say I1 is a start button, and we know a start button is normally open. Okay, so what happens is we've got a 1 or an on, but it's being stopped by the start button, so the input reads a 0. The moment I push that button and it closes, then I1 connects to the positive supply and it reads an on value. Second type of value is, let's say, a stop, which is a normally closed switch. That normally closed switch is connected to the positive supply, so it receives a logic 1. When we push the button, then it breaks the connection and it reads a logic 0. Those are the digital inputs. Next, we've got analog inputs. An analog inputs is a device that, well, the analog inputs are devices that we use to connect to a sensor device. We'll go into more detail regarding sensors in a later video, but when connecting a sensor device, we always connect the device. This is the incorrect symbol, but this circle over there represents my sensor. Typically the sensor is a device that changes its resistance in accordance with the voltage or its value that it is measuring. It's connected in series to develop a voltage divider bias, and then that connecting point between the sensor and the resistor will connect to my analog input. So as the sensor changes its resistance, it's going to change the voltage across itself, and that is what my input, my analog input, is going to measure. Now, when using an analog input, it is imperative that we use the analog testing. In our ladder diagram. As an example, let's say input A7, analog input number 7, that's that one over there. That one is going to connect and conduct a logic test, whereby it is going to switch on when it measures a certain value. In other words, you're going to program and say if it measures 5 volts, then it must turn on, and when it measures 4 volts, it must turn off. Okay, you can also set the gain or the offset, in other words slight delays. But then this, okay, this is labeled SF001. This will then connect in my ladder diagram as an input that is going to control a specific output or a memory aspect on the PLC. Now, different sensors will be discussed in a later stage.